Okay, so we're going to get started again. This is part 2 of the Unity's new networking system. So this is actually a modified version of the presentation that was given at Unite in Seattle last year. So for people who weren't in the last session, hello, I'm Sean Riley. I work on the Unity networking team. So I just want to talk about some high-level concepts to get started. Server versus host. So most network architectures have a server and multiple clients that connect to a server. And I'm going to talk about this as the host is the client that's running the server. And in our network architecture, there's often a relay server in between the clients and the host. So if you're running a server on the internet, you need a public IP address for other people to be able to connect to you. And most devices, mobile devices especially, don't have a public IP address, so you can't just connect from one phone to another over the internet. It's a problem for multiplayer gaming because you need to talk to each other. So our solution to that is the relay server, which sits in the cloud, and it has a public IP address, and then everyone connects to it, and traffic gets routed that way. So in Unity, the words instantiate and spawn are usually used to mean the same thing. In the networking system, we use these words slightly differently. Instantiate is an actual API call, and it means to create a new Unity game object. So gameObject.instantiate creates a new object. And we use the word spawn to activate that object on the network. So when an object is spawned on the server, it gets created on all the clients that are connected to the server. And then the spawn system is the thing that manages all of the spawned objects across the clients and the server. So another piece of vocabulary we have in the high-level API is local player objects. So in this little diagram here, we have a server, and we have 2 clients, and there's 1 player on each client. But there's really 2 players on each client because there's the player of the other client on your client. So there's something special about the client objects with the circles around them. Those are the ones for you. So this is on client 1, player 1 is your player, whereas player 2 is someone else's player. And that's important for your code because you don't want your player to behave like other people's players. So the camera should be following your player, and input should be processed for your player. But for other players, you don't want those things to happen. So this is a concept of the high-level API, local player objects. And there's a property on the object, so you can check at any time to say, is this my local player? And then there's a callback function that's invoked when an object becomes a local player. So you can do setup in there, like attach a camera or things like that. And other scripts on the object have access to that property, so you can do special things in any of the scripts based on whether or not it's a local player. And the network transform, it does that. So if it's a local player, then the network transform will send information about positions to the server for that object. So if I extend that a little bit, here we have 2 players, and we also have an enemy. So who is the local player for the enemy? No one. But for objects that are not local players, authority resides on the server in the high-level API. So there's another property actually, which is is authority. And this will be true. In this case, it will be true for that enemy object on the server. But it will also be true for a player object on the client. So there's a property for that, there's a callback for it. Local players have authority. And this is useful for systems that work on both enemies and players. So an animation system or a combat system might run on both player objects and monster objects. And it's useful for that system to know wherever it's running, whether it has authority at that particular time. Okay, so that's all the concepts. We're going to do a demo. So we're going to start with a single player game and turn it into a multiplayer game. So it's a pretty simple 2D shooter game. It's got a little spaceship, flies around and shoots these slime aliens. Okay, so here we go. You can shoot bullets, fly around, shoot the aliens. They have health bars, and they explode. And that's the game. So I'll do a little tour of this game to start with. There's one scene. In the scene, we have a ship. He has 2D physics, rigid body, circle collider, a sprite renderer. He has two scripts. We have a control script and a combat script. Also in the scene, we have camera. We have our back plane. Let me go to the scene view. There's a light. There's a spawner object, and the spawner has a script on it to spawn aliens. And you can see there's a slot on this script here, which we dragged our slime alien prefab into. And we have a bunch of walls, and then there's this game manager thingy. Okay, so in the assets here, we have our images, default materials. So there's a prefab for a bullet, prefab for our explosion, prefab for our ship, and he's got some thrusters on him, which are just connection points for the particles, and then our alien. And the alien has a combat script, the same script that's on the players, and it has a slime alien script. And that just makes him move towards the player objects. Very simple. Okay. So, to make this game multiplayer, these are the steps we're going to take. So we're going to add a network manager to the scene and hook it up. Then we have to network our player movement. We have to network our bullets. Then the combat system has to be made network aware, so our health and our damage. Then the aliens will have to be made networked objects. Then the ship thrust particles are a little bit more complicated, so we'll do those later. Then we have to have spawn positions, so we don't want players to all enter the game on top of each other. And then at the end, we'll add a lobby, depending on how much time we have. So, basic hookup. Okay, back to the editor. Okay. So, I'm just going to create a new game object. And I'm going to rename this to the Network Manager. And then we're going to add a component. Well, let's see. So in the component menu here is a new entry, Network. And under Network, we have a Network Manager. So the Network Manager has advanced stuff at the bottom, but the important stuff here, just going to do the minimum required to get running here. We have some slots for scenes here. We don't need to use those since we only just have one scene. but we do need to set up our spawn info. So we have a slot here for the player prefab. And what that means is that when a client connects to the game, we're going to create a ship for them, and that's going to be created from the ship prefab. So I'm going to take my player prefab and drag it into that slot. And we got an error. So for objects to be networked, they need a network identity on them. So let's go to the ship object here, and we'll give him a network identity. Network identity. And the network identity identifies objects across the network, gives them IDs at runtime. And there's a checkbox here, local player authority, and I know I'm going to be running my ship controls on the client, so I'm going to check that box. Okay. So let's go back to the network manager. So now I can take my ship and open that spawn fold out. Now I can take my ship prefab and drag it into here, and we have a ship object. So auto create, sorry, can't read that. There we go. Auto create player is checked, which means that when a connection is established, a ship will automatically be created. But there's a ship in the scene already. In this case, we don't want that, so I'm just going to delete that ship from the scene. Hit save. Now when I hit play, what happens? Well, nothing happened. Well, that's because the network wasn't running. So we need a way to say we start a network game. When the player starts up by default, the network doesn't get started, so nothing happens. So we have a utility component here to give us a user interface for that. So the network manager HUD. And when I add that to my network manager, and now I get these buttons here. So host, connect as a client, start as a server, or use the matchmaker. And the matchmaker is for internet play. So we're just going to run a local game. So I'm going to hit start as a LAN host. And you can see now we have a player ship created. And it just works as normal. I can fly around. Okay. So I'll make a build. And here's one client. I'll start another one. Oh, really? Okay. So this one is going to be my host. This one here is going to be the client. Let's see what happens. Bang. And you can see there's now two ships. It's not quite working properly. So there are two ships. If I log out, you can see the ship disappears. I log back in, I get a new ship. But we have some problems. So bullets don't work properly, aliens don't work properly, movement doesn't work properly. But their basic network identities are set up. So the next thing to fix is player movement. So let's go back to our ship. So on the ship prefab, I'm going to add a network transform. So the network transform automatically realized we're using 2D physics, so it's going to synchronize our rigid body. We have a slider here for how often to send updates. I'm going to set that to 14 times a second. Then there's some advanced configuration, but we don't have to worry about that too much. Okay, so now if I do a build, we should see some movement synchronization on our ships. So again, this is the host. This one is the client. And we can see ships are moving around. Still, there's some problems here. My camera is following the wrong ship on this one here. Yes. Okay. So, to fix that, we're going to have to write some code. You notice we haven't written any code yet. So let's go to our control script here. So this is a script that's on the ship. You see here I'm importing the network namespace, and I'm going to change the base class from a mono behavior to a network behavior, and this is a new base class for network scripts. So let's do a quick tour of this script. So we have some constants for tuning. We have the prefab for the bullet. We have our thrusters. Then we have some variables for controlling thrust and spin. So in the physics fixed update, in the physics, if our thrusting is set, then we apply some physics. If our rotation is set, then we spin a little bit. Then we have an update function where we look at the keys, and if our key state is different than our old key state, then I call this thrust function to make the ship move. Then if the spacebar is pressed, we shoot a bullet. And then each frame we're updating the position of the camera to look at the ship. And then these two functions do thrust and do fire. Pretty simple. Okay, so in the update function, let me get my timer going again. In the update function, it's doing lots of things that we don't want done for every player. So instead of doing that, we're going to look at the base class here. Oh no, command completion. Okay, so there are properties on the base class that we can use to fix this. So there's a property called isLocalPlayer. And if you remember back from our diagram earlier in the presentation, that's only set for your player object. So in this case, we want to say, if this is not the local player, then return. And I'm going to also do that in our physics update. So now, for your player, keyboard handling will be done, and the camera will be centered on the player, but for other players, that should not be done. Okay, so let's go back here. We'll do a build. Run my client. So this is our host. Oops. This is my client. And now the camera is centered on the player, and he moves around. You can see him on the other screen. And when I go over here, the camera is centered on the right player, and he moves around. So we're getting there. Bullet's not working properly. He's only firing here, only firing here. I think that's next. Okay. Bullets. So, messages sent from the client to the server, we call these commands. And you can only call commands on your player object. And this uses the local player concept again. So you can't make someone else's ship fire bullets. You can only make your ship fire bullets. So in our update function, you can see when the spacebar is pressed here, we call this doFire function. So I'm going to turn this doFire function from a local function into a remote server function. So the way we do that is we add a new custom attribute to it. And this is another attribute. This is a custom attribute in the networking namespace. And I give it a prefix, so command do fire. And then I'll change this to be command do fire. And now, instead of being called on the client, this function will now automatically be called on the server. That's what the command attribute does. So, build. And it's going to be the host. This is going to be the client. Aliens are in the way. Okay, so now when I press the spacebar on the client, fly back over here. The bullet is being created on the server, but not on my client. Something's wrong. Let's see, what's this one here? The bullet's only being created on the server. So, the reason for that is that we didn't tell the client about the bullet. And we don't automatically instantiate those objects across the network. There's a API call you have to do for that. So, and that API call is network server.spawn. If you remember our terminology, instantiate is the first call that created the game object, and then spawn actually causes that object to be created on the network. And once an object is spawned, the server remembers it so that if new players join the game, they'll automatically be sent the latest data for that object as well. So now when my client joins and I fire, something happened. Got a big red error message. Bullet has no network identity. Okay, that seems reasonable. We have to add a network identity to our bullet. So I'll go to the bullet prefab. Go away. Here we go. So go to the bullet prefab, network identity. I also am going to add a network transform to my bullet. So bullets don't change direction after they've been fired, so I don't need to update the position of the bullet in real time, so I'm just going to drag that down to 0. So bullets are fire and forget. So now when I fire a bullet, we'll see what happens. Okay, so my host, client, and now when the client fires, invalid asset ID. There's one more step. So the network manager, remember we added our player prefab here to the network manager. There's also a list of registered spawnable assets, and I have to add my bullet here. So this is a manual step to give you more control over load times. So every asset that's registered in the network manager will be loaded as part of the scene. You don't always want every possible asset that could be loaded by your scene to be loaded on the startup of your scene. So this lets you choose which ones get loaded when the scene is loaded. Okay. So now maybe our bullet will get created. Oops. Click. Here's the host. You can fire bullets. And when the client comes in, bullets. So bullets now show up on the client and the server. Notice our aliens are in completely different positions and have different health, and our ships have different health values. So we're not done. Okay, commands and spawning. So next, talk about health, combat. So in our server authoritative game, health should be controlled by the server. So let's go to our combat script. So this script is on the ship and it's also on the aliens. And the script has a value for health. It has a function, take damage, another function to make explosion. It has a respawn function and it has some GUI to draw the health bars. And the take damage function is called by bullets. When the bullet hits anything, it calls the take damage function. So health, we need to make a server authoritative variable. And the way we do that with, we need to make this a network script. So I need to say import our namespace and change this to be a network behavior. Okay. So once we're a network script, I can use sync vars. And a sync var makes a variable automatically be synchronized between the server and the clients. So anytime health changes on the server, a message will be sent to the clients to say this is your new health value. And if a player joins a game in progress, they will be sent the latest state of all the sync vars for an object. So that's pretty easy, but we want to also do explosions. Let me just check this. Right, taking damage. So we have this take damage function, which modifies your health. And now we only want this to be called on the server. So, okay. So I'm going to add a check here to say, if we're not on the server, then return. And this is another property provided by the network behavior that gives you context. So now if a bullet hits an object on the client, the bullet's going to call take damage, but it won't do anything. It'll just exit immediately. And on the server, it'll come in here and the health will be modified, and then the message will be sent to the client to change the health. So now this code now will only run on the server. So let's take a quick look at this code. So we change the health, and we check if your health is less than 0. If it is, we make an explosion and respawn you. So let's say we want to make an explosion every time you take damage, just a little explosion. So one way to do that is to add we call it a hook function. So I can add a hook function to this sync var. So, on damage. And the hook function will be called on the client when the health changes on the server. So in here I'm going to say if new health is less than 100, which I know is your maximum health, then make explosion. And we'll make it a small explosion. And then health equals new health. And my make explosion function, I just need to add a parameter to it here, length. So now we can make different size explosions. Okay, so when we take damage on the server, the value will change, function called on the client, explosion will be created. But here, this is not quite what we want anymore. When you die, this code would only run on the server, so we wouldn't see an explosion on the client. So So I'll just comment that out for now. We'll fix that next. Let's just see if this works. Oh, no. Thank you. Okay. So let's test this out. So there's my host.